Imagine a silent digital factory where millions of decisions are made every single second, completely untouched by human hands. Every time you book a flight, process a payment, or stream a movie, a complex web of invisible logic springs to life, orchestrating thousands of servers in perfect harmony. This is not just automation. It is the rise of the programmatic workflow, the hidden engine rewriting the rules of the modern digital economy. For decades, humanity has chased the dream of the self-running machine. Early automation was simple and fragile, relying on basic cron jobs and static scripts that executed repetitive tasks at scheduled intervals. If a single network packet was dropped or a server stuttered, the entire chain collapsed, requiring manual intervention to rebuild. But today, our digital demands are too massive, too complex, and too fast for fragile scripts. We have entered the era of programmatic workflows, where automation is treated not as a series of disconnected tasks, but as a living, breathing software application. This paradigm shift treats workflows as code, enabling developers to build, test, and scale complex operational logic with the exact same precision they use to build core software. To understand how this functions, we must look beneath the surface at the mechanics of modern software architecture. Programmatic workflows rely on three fundamental pillars: APIs, event-driven triggers, and state machines. An API, or application programming interface, acts as a digital bridge, allowing entirely different systems to communicate seamlessly. In a programmatic workflow, events act as the catalyst. A user uploads a video, a sensor detects a temperature spike, or a transaction is flagged as suspicious. This event fires a signal through the architecture. Instantly, a state machine, which is the brain of the workflow, evaluates the current status of the process and decides the next logical step based on predefined rules. It manages state transitions, ensuring that if step B fails, the system knows exactly how to roll back to step A or safely retry step C without losing critical data. In the world of distributed systems, managing these processes requires a choice between two distinct patterns: choreography and orchestration. Think of choreography as a decentralized dance where each service acts independently, listening for specific events and reacting. While highly flexible, it can quickly turn into chaos as systems grow. Orchestration, on the other hand, introduces a centralized conductor. This is where programmatic workflow engines like Apache Airflow, Temporal, or Prefect shine. These platforms act as the ultimate conductor, writing the sequence of tasks in actual code, usually Python or Go. By defining the workflow programmatically, developers gain complete visibility. They can visualize dependencies, track the exact path of execution, and dynamically allocate computing resources to where they are needed most, creating a resilient, self-documenting system. Perhaps the most critical superpower of programmatic automation is its inherent resilience. In a traditional IT environment, a network hiccup or a third-party API outage can cause catastrophic failures. Programmatic workflows solve this through advanced fault tolerance mechanisms built directly into the runtime. When a task fails, the system does not simply crash. Instead, it initiates an intelligent retry policy with exponential backoff, waiting progressively longer between attempts to avoid overwhelming the target server. If the failure persists, the system can trigger saga patterns, which are a series of compensating transactions designed to undo previous steps and restore system balance. It is a self-healing ecosystem that guarantees eventual consistency, meaning no matter what failures occur in the physical or digital infrastructure, the system will eventually reach its intended destination. We are now standing on the threshold of the next major evolution in this space, the integration of artificial intelligence and agentic workflows. Historically, even the most complex programmatic workflows were deterministic, following strict pre-programmed logic paths. But by injecting large language models and machine learning agents into the loop, workflows are becoming cognitive. An AI agent can analyze unstructured data, make real-time decisions, and dynamically alter the execution path of a workflow based on context. Imagine a customer support system that does not just route tickets based on keywords, but understands the emotional urgency of an email, writes a custom patch, runs it through an automated testing pipeline, and deploys a fix, all within minutes. The programmatic workflow becomes the scaffold, providing the guardrails and structure within which creative AI agents can safely operate. As we look to the future, the boundaries of what can be automated will continue to expand. Programmatic workflows are evolving from a developer-only tool into the foundational fabric of global enterprise. We are moving toward a world of hyper-automation, where physical supply chains, financial markets, and creative endeavors are integrated into a single, continuous loop of optimization. The organizations and individuals who master these programmatic structures will possess an unprecedented level of leverage, turning complex operations into code that runs flawlessly, endlessly, and autonomously.